Okay, so in example 6, they define dictionary order as we know it. So they go back to having a single set, simply because if you have multiple sets for this one, it becomes very, very difficult to process, even though really it works out to be the same. But what we haven't covered with our definition of lexicographic order yet is what if the tuples are different size. So far we had a 2 tuple, then a 3 tuple, and we showed how that could be extended to any numbered tuple. But what if one is, a different size than the other one? For that, we need the concept of an empty string. And we're going to introduce that with our definition of dictionary order. I'm going to go through this one. It's kind of interesting, but honestly, it's not strictly necessary. There might be one homework problem that asks about this, but it's not an integral part of understanding sets, whereas lexicographic order really is. So let's say that we have some set S, right? It is some set with a finite number of symbols. We could assume the alphabet, right? That makes sense. And let's say that when we say S of k, that means the product of S with itself that many times. So this means, x1, x2, x3, ... all the way up to x sub k, which are all members of the set S. Those two statements are equivalent. All right? Let's also define S sub 0 to be a special string. It is the empty string, right? It has no characters from set S, but that's still a value. It has nothing from set S. And finally, let's define S of star, which means from k at 0 all the way up to infinity, every S sub k. So S star is basically every possible string that you can make within the set of S. And it's an infinite set. Everybody with me? I don't know why I'm asking if you're with me. You can't answer. I'm assuming you're with me. If not, pause this, rewind it, and go over it again. Now let's say we have two strings, A and B. So we're going to define A as A1, A2, all the way down to A sub M. And we're going to define a tuple or string B, which is going to have B sub 1, B sub 2, all the way down to B sub N, right? So these two strings may have different lengths. There may be more symbols in one tuple than the other. All right, we say that A is, and I should put the little L there for lexicographic, but I'm just going to use less than or equal to. But there should be an L there, right? We say that the A string comes before the B string if either of the following conditions are true. If M is less than or equal to N and A sub I equals B sub I, for I equaling 1 going all the way up to M, right? So remember, M is less than N. So in this case, assuming the first one to be the A string, it does come before the B string because M, the last index, is less than N, the last index of the B string, and for A sub I equals, so for I equals 1, they're the same. For I equals 2, they're the same. 3 equals the same. 4, they're the same, right? Which is totally intuitive, and we've seen that a million times. We're just formally defining that here. The second case where A comes before B is that there's some value k. This is a totally unrelated k to what we've been doing. Just some value k that is smaller than the minimum of M or N. So there's just some number that's smaller than the last value of the smaller string. And A sub I equals B sub I for I equals 1 all the way up to k. But A sub k plus 1 does not equal B sub k plus 1, and A sub k plus 1 is before B sub k plus 1 in the ordering of our set S. So let me give you an example of that. Let's say that we have the words cleaner and cleaning. And in this case, our k is going to be 1, 2, 3, 4, 5. So k equals 5. So, and 5 is less than m, which is 7, right? So 5 is less than m, or n, doesn't matter. But 5 is less than 7. And it's saying for I equals 1 to k, right? So for I equals 1, A1 equals B1, true. A2 equals B2, A3 equals B3, A4 equals B4, A5 equals B5, right? So this part is true. But A k plus 1 not equal B k plus 1. And in this case, that is true, right? I probably should have aligned these a little bit better. A k plus 1 and B k plus 1 are not equal. And A k plus 1 is less than B k plus 1. Well, we do know that E comes before I in the alphabet, right? So assuming that ordering, in this case, cleaner comes before cleaning. So if either of those two cases are true, then string A comes before string B. So we now have a formal definition of true dictionary ordering for any size string, any size tuple. Now, does this agree with what we did in example 5? It certainly does. If both strings A and B, if m and n are the same size, then this will still tell us the correct ordering. You'll get the exact same results as you did with example 5. It's only when the strings are of different sizes that this definition becomes important. Okay, that's all we're going to say about ordering of sets. It's important to understand mostly because in real-world applications, your sets are ordered. If you have any questions, ask in the comments below.